So you want to build a Bluetooth enabled doorbell that you can build in a day? Hang around and I'll show you how I built an Uber doorbell complete with smartphone application, all built from within the Arduino IDE. I mean, a plain old doorbell is boring, right? You're probably wondering why I didn't just go down to my local hardware store and pick up a cheap doorbell. Here's why. Yeah mate, I just got this one delivery and they'll be home. Oh look, if they're not here by the third bell press, I'm just gonna go, I reckon. Yeah mate, alrighty. I wanted to build a doorbell with a basic set of features that I could extend later. And once I had that basic platform, I could build on features such as being able to talk to the person who'll push the button without being at home. So this Uber doorbell tutorial will set you up with the basic features. Produce a customized sound when the doorbell is pressed, log doorbell presses and door closes that you can view from your smartphone, and allow you to mute the doorbell if you want to. I selected parts that were as cheap as possible. Here's what you'll need. You can check out this parts list down below or on my website. A lily pad assembly, vibration or knock sensor, real-time clock. Any I2C based RTC will do, but I used a cheap DS3231 based RTC. You'll also need a doorbell button. I found this in my shed. You'll also need a LiPo battery. I used a 150 mAh battery, and also an amplifier and speaker. I used a PAM 8403 based amplifier, which allows you to power down the circuit, great for long battery life. The LilyPad has 7 GPIO ports available, and we'll be using all of them, plus also stealing the LED pin. I soldered up a simple button that will act as a doorbell whilst I tested my code out. One end connected to pin 3 and the other end to ground. Next I temporarily soldered up another button to act as a vibration sensor. One end soldered to the ground point of the assembly and the other end to the GPIO pin 11. I used internal pull-ups on the assembly, so there was no need for external pull-up resistors. Next I connected up 2 GPIO pins together. I have a more detailed description of why I had to do this on my website, but simply it allows the assembly to drop into ultra low power mode and wake up when you connect to it from your phone. This will greatly conserve battery power. Removing the header pins on the RTC breakout board is easy enough, and I cut 4 coloured coded wires to solder up to the board, with the red wire soldered to VCC, the blue wire for SDA, the white wire for SCL, and the black wire of course for ground. It's always important to cut off any extra wires sticking out to avoid short circuits. I temporarily held it in place with Bluetech and then soldered up the VCC wire to the assembly VCC, then the ground wire to ground, then the 2 I2C wires SDA and SCL. With the temporary knock sensor and doorbell button in place, I was able to write the code and test out the logic. Once I was satisfied, I desoldered the temporary button and soldered a wire to one pin of the knock sensor, making sure I used heat shrink to avoid any short circuits. Bent one of the pins so it would sit flush on the board, and then soldered one end to pin 11 and the other end to ground. Okay, it looks a bit like a dog's breakfast, but everything is secure. Next I soldered up the audio amplifier. This required me to desolder a few components so that I could get access to the GPIO pin 13. This is currently connected to the onboard LED. Desoldering surface mount devices usually requires special equipment, especially if you want to use them later on. In this case I didn't care about the LED, so I just applied enough heat to melt the solder and push it off the surface mount pads, being careful not to splatter solder everywhere. Just to be sure, I inspected the board up close by using a magnifying lens of the kid's telescope and a pin to scrape away any solder. You can see a few solder bridges that I had to remove. I cleared it up as best I could and managed to clear enough away for it not to be a problem. Next I soldered up a yellow wire to the pin 13 pad and soldered up the knock sensor wire underneath the RTC so it wouldn't get in the way. Dog's breakfast again. Then I soldered the RTC back in place. The amplifier requires 3 additional wires: ground, VCC and audio out. First I soldered up the VCC, then ground, and finally audio out. You'll see that I used just the left channel on this amplifier. I then secured it to the lily pad with hot glue and soldered up the ground wire, VCC, audio out, and finally the amplifier enable wire that was hijacked from the LED pin. Not so much of a dog's breakfast on this side. Next I soldered up 2 wires to a standard 8 ohm speaker, which I then soldered to the left channel of the mini amplifier. Next I measured the width of the door, as the button wires had to be long enough. I used standard breadboard hookup wire, which were cut in half and allowed me to keep the button and unit separate. I tinned the wires, desoldered the old temporary button, and soldered up the hookup wires. One thing to note with this particular button is that it had an inbuilt light which had to be removed. Later on I put an LED in its place. Next I attached the opposite end of the hookup wires to the button. And that's it for the wiring up. I then went to the plumbing section of my local hardware store and picked up a storm water cap and plug. These make ideal cases for small projects, and the entire doorbell assembly fitted in nicely. Next I looked up and printed out a sheet of grid paper, which I used to mark the holes for the speaker. I used the storm water cap as a rough guide and very roughly cut out the circle. It really doesn't have to be accurate. Then stuck some blue tack on it and placed it on the cap. I used a spring-loaded punch to mark the holes for drilling. I ended up using every second point, as I didn't want to spend 5 hours drilling holes. It doesn't matter if you mark more holes than you need. Once you have the holes punched, place the speaker in and mark it out as guide for drilling the holes. Now it's off to the drill press. First of all, I drilled a large hole in the base plate for the button wires, then started the laborious task of drilling all the speaker holes. If I was going to do it again, I'd be a little more careful marking out the holes, as they weren't that even. I drilled from the other side just to tidy things up. Then drilled the 2 holes for the door mounting screws. You won't see them, so it doesn't have to be accurate, just make sure they're long enough. Now back to the front door. I used a spade bit to drill a hole in the centre of the front door. Check to make sure you don't drill all the way through, otherwise you'll splinter out the wood on the other side. Once the tip is broken through, you can drill from the other side. Then mark out the screw holes in the button plate, drill the holes, and screw the button plate on. If you've measured correctly, the button wires should protrude out enough. Now mark out the screw holes for the box. Drill the holes and screw the box to the door. You don't need to screw it up tightly, just enough to hold it there. Next, secure the speaker in with hot glue and place all the components in the box. It was a tight fit, but everything eventually went in. Another issue I ran into was the fact the speaker protruded out the back too much, so I marked out on the base plate where the speaker sat and drilled out a hole for it to sit into. Then all was left was to attach the button wires and push the cap on. And it worked as expected. All that's needed now is to install the Assembly app on your smartphone and connect to your doorbell. The app I wrote is fairly basic but has all the things I initially wanted. You can select the log button and view doorbell presses and door movements, and set the date and time on Assembly by entering in numbers or using the sliders. You can also ring the doorbell from this app, or mute it altogether. So there were several things I learnt with this project. After several days, the 150 mAh battery ran flat. So I'm going to have to look at a bigger battery, or look at optimizing my code some way. 2. When drilling holes for something that's visible, take extra time to be as accurate as possible, otherwise it'll look a bit messy. I plan to make a follow-up video with additional enhancements while keeping the cost down as low as possible. Let me know in the comments below if you have any ideas for improving it, or if you make one yourself. It'd be great to hear from you. You can check out further details on my website, complete with parts lists and links to suppliers, and a link to GitHub where you can download the Uber doorbell code. If you like my channel, you can subscribe by clicking on the logo below, and I really appreciate all the feedback and support you guys are giving me. Thanks a bunch.